is gonna be formed by the non-metals. See, an ionic bond is gonna form when the force electrostatic force between a positive charged particle, which is the metal, because the metal is the one losing electron, is gonna be attracted to the negatively charged ion, which is the anion, and the anion is gonna be formed by the nonmetals, because the nonmetals, they have more electronegativity and more, okay, and more ionization energy. Okay, this is Miss Ramos' way. Keep that in mind. I'm creating a video. I'm gonna post this video on YouTube, and then I'm gonna share the link through the stream of Google Classroom, so you can refer to this later when you are explaining how an ionic bond is forming. In addition to explaining ionic bonds using the electron configuration of the elements, I'm gonna introduce oxidation numbers, and I'm gonna introduce naming ionic compounds made of representative metals and monatomic ions. Okay, so we're gonna start with the first example. Okay, first example, and I'm gonna use the example that I was using on the first video that I was posting: calcium and oxygen. So when you have a metal and a non-metal that are combining chemically, immediately, how you gonna classify that bonding? As an ionic bonding. See, just by looking at that, metal, non-metal, I have an ionic bond. What is gonna happen during an ionic bond? Yeah, I'm gonna start with the atomic number for calcium. Calcium atomic number is 20. So I have 1s2, 2s2, 2p6, 3s2, 3p. A ver, let me see. It's in group 2. In group 2, a ver, I have over here period. What period is calcium? Period 4. No. 3p6, 4s2, 3d10. Let me see if I'm right over here. 2, 4, 10, 12, 18. Okay, 20. 20 over here, meaning that this one over here doesn't go. You know how, see, oh, how can I erase that? Doesn't go there. That one doesn't go in there, because I already have my 20 elements. Now, look over here. Last level of energy for calcium in the orbital S. In order to reach chemical stability, calcium has, see, to put on the last level of energy A electrons. A electrons. See that? But calcium has only 2 electrons in the S orbital. It's easy for calcium to let go those 2, or just to accept 6 more. Okay, so it's gonna be easy for calcium just to let go these 2 over here. And when you look at level number 3, 2 plus 6 is equal to the A electrons. That's what is happening in an atom of calcium. In order to reach chemical stability, calcium is gonna be losing the 2 electrons in the last level of energy. But now you have 20 protons. After losing those 2 electrons, losing 2, 4, 10, 12, 18, you have only in that calcium atom 18 electrons. If you do the math, you will realize that by losing those 2 electrons in the last level of energy, calcium is gonna be converted into cation with a positive 2 charge. That positive 2 that you have on top is the oxidation number. Oxidation number, which is the charge of the atom after losing or gaining electrons. Are you able to see my screen? Yes or no?
Yes, miss. Yeah.
Okay, now I'm going to use another color because remember that I'm combining calcium and I'm combining oxygen. Oxygen atomic number is 8. Over here, 8. Number of protons, meaning that the number of electron is 8. So this is over here. Okay, let me put, this is for calcium. Now I have oxygen in here. 1s2, 2s2, 2, 4, 4, 4, P4. Okay? Look at the last level of energy. Last level of energy. Remember, according to the Opter rule, in order, see, this is what I'm going to do over here, because remember, in the p orbital, I have 3 orbitals, and all my electrons, they are accommodating, following the Hunt and the Pauli exclusion principle. Okay? I have, see, 6 electrons in the last level of energy. They are not completed, okay, because they don't have the 8. It's gonna be easy for oxygen to let go the 6 or just to gain 2. See that? The 2 over here that calcium was given away, what's gonna happen? They are gonna be part of the p orbital in the oxygen atom just to complete the A electron in the last level of energy and just to reach chemical stability. But what's happening in that case? That now in the atom of oxygen you have 6 protons. But when you were adding the 2 electrons from the calcium to 4 plus 6, now you have, okay, let me see, what is the atomic number? No, it's 8. The atomic number 4, the atomic number of oxygen is 8. So you have the 8 protons plus 2, 4 plus 6, the 10 electrons after gaining the 2 electrons in the p orbital to reach chemical stability. If you do the math, okay, -2, A positive plus -10, -2. And after, okay, gaining those 2 electrons, what's gonna happen? Okay, oxygen is gonna become an anion with a charge equal to -2, and that number over there is called the oxidation number. See that? Okay, so now you have calcium that is giving away 2 electrons, and then you have oxygen that is accepting the 2 electrons. This is the chemical formula for the ionic compound that is formed after calcium is reacting chemically with oxygen. This is the chemical formula. Miramos, we don't have over here any subscript. You don't need it because calcium was losing 2, and those 2, they were accepted by oxygen. So the ratio, the combination ratio was 1 to 1. From 1 electron that calcium is losing, oxygen is getting that. Okay? No, yeah, we lost the connection. ¿Qué pasó? We lost the connection. If we were talking about the chemical formula, since you have 2 electrons that calcium is given away, and then you have those 2 electrons accepted by the oxygen, they are gonna be combining a 1-to-1 ratio because one is giving two away and the other one is accepting the two away. And when you look over here, that's the formula, the chemical formula that you're gonna use to write the ionic compound that is gonna be formed. Okay, so Miss Ramos, how are you gonna name this? CaO is the chemical formula for the ionic compound. How are we gonna name that ionic compound? And the answer is super easy. The cation. Never, 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 never change the name. So we are gonna keep that as calcium. The anion. Okay, you're gonna drop the ending and then you're gonna add IDE. I'm pretty sure that many of you remember this. So what is the name of this ionic compound? Calcium oxide. Oh, Miss Ramos, but we have questions. The elements, are they gonna combine always in a 1-to-1 ratio? If the answer is no. Remember that every time that you have a metal and a non-metal, okay, an ionic bond is gonna be created and an ionic compound is gonna be formed. So now we're gonna combine another, see, elements, like two different elements. We're gonna combine lithium and we're gonna combine lithium with chlorine. Chlorine no. We're gonna combine that with sulfur. We're gonna combine that with sulfur. See, the moment that you see that a metal is combined with a non-metal, see, you can say it right away. We have an ionic compound because the bonds are ionic bonds. The metal is gonna be losing electron and the non-metal is gonna be accepting that. How? Yeah, I'm gonna start with the electron configuration for lithium. 3, 1s2, 2s1. Look at the last level of energy over here. A electrons, no. Remember that in order to reach, okay, chemical stability, the elements, they need a electron in the last level of energy. Sulfur, let me see, 17, no, 16. So I have 1s2, 2s2, 2p6, 3s2. So far I have 12, 3p4. Let me see if I have 16 in here. 2, 4, 10, 12 plus 4, 16. Oh, Miss Ramos, this one over here, see, in order to reach chemical stability, is gonna be losing this one. Are you sure? Look at level number 1. Do you have 8 in there? Oh no, Miss Ramos, we don't have 8. But Miss Ramos, you were teaching us that in level 1, the atoms, they are gonna be accommodating only 2 electrons. So by removing that one from the last level of energy or lithium is gonna be able to reach chemical stability because now lithium is gonna have only 2 electrons in the first level of energy and the first level of energy is gonna be able to hold only 2. So by losing that one, lithium is gonna become a positive cation, a positive ion with a charge equal to +1. And I'm pretty sure that you know how to do the math. The math. You have 3 protons, but now you have only 2 electrons, +1. Oh, Miss Ramos, when I was looking at your explanation, I have realized one thing, that lithium is located in group 1. So, see, the oxidation number is closely related to the group number. Yes, yes it is. All the elements that are located in group 1, the oxidation number is +1. Plus, because they are losing the electron. 1, because they're going to be losing only 1 electron. Does that make sense? Oh, Miss Ramos, now I understand that. Calcium is in group 2. It's a metal, so it's going to be positive, and calcium is located in group 2, so the oxidation number is going to be +2. Yes, you're right. The number The group number is closely related to the valence electron. It's giving you the valence electrons, so you can infer the oxidation number looking at the group number. Oh, mira, what's going to happen with sulfur? Mira over here, let me draw this one more time. I'm going to draw this one more time. In the last level of energy, even though the s orbital is filled with the 2 electrons, look at the situation that we have in the p orbital. We need 2 more, Ms. Ramos, but we have only 1 for lithium. We have only 1 for lithium. What's gonna happen in that case? How many more ions of lithium do you need to complete this one over here? You need another 1 of lithium just to complete that p orbital for the sulfur atom that, by accepting the 2 electrons from the 2 lithium's ion, is gonna become a negative ion. Oh, Ms. Ramos, I have realized that when I look at the periodic table, sulfur is located in group 16. And it's located in group 16 because it has 6 valence electrons. How many more to reach a 2 more? So it's accepting 2, the 2 is coming from there, and negative because it is a non-metal. Miramos, that's the way that we infer the oxidation number by using the periodic table. The answer is yes. Okay, now we have a problem, Ms. Ramos, here, because instead of having 1 lithium ion to complete the p orbital of the sulfur atom, we were using 2 lithium ions. So let's say that we want to write, okay, the chemical formula for the compound made by lithium and sulfur. You were needing 2 ions for lithium per 1 of sulfur. And this is my chemical formula of that ionic compound that was formed. But Ramos, how am I gonna name that ionic compound? The cation is gonna change the name? No. Lithium. And what's gonna happen to the anion? You're gonna drop the ending. What do you have to add? Sulfide. Questions about that? Ms. Ramos, there's a way to do this like in an easy manner. See, in a way that we don't have to analyze the electron configuration, all of that. Yeah, it's an easy way. Are you ready for that? Okay. We are gonna put together magnesium and nitrogen. But we're not going to use the electron configuration because I was using the electron configuration, and you know how the electrons that the metal is losing, okay, to reach chemical stability, they're going to be accepted into the orbitals of the non-metals. So I'm not going to use that approach anymore, okay? So magnesium, I'm going to look at the location. Now I'm going to start using, see, for the approach that we're using before, I have the atomic number, but I didn't have the periodic table. Now, for this approach, I'm going to look at the periodic table. And magnesium is located in group 2. How many valence electrons? 1 and 2, like that. Not the 2 together, not like this. This is wrong in there, okay? So 1 and 2. And then I'm going to look at nitrogen. But nitrogen is located in group 15. You're going to cover the 1. How many valence electrons? Only 5. Organize it this way. 1, 2, 3, 4, 5. Okay, these 2 over here, they're not ready for bonding. What are the ones that are ready for bonding? The 3 that you have over here. Oh, Ms. Ramos, so now how we're going to analyze that? Okay, remember, in order to reach stability, what's going to happen to the metal? Is gonna lose those 2 electrons, okay? And it's gonna become a positive ion. How many was losing? 2. See that? In order to reach chemical stability, Nitrogen needs to gain 3 by becoming an anion. Is gaining -3. Y miramos those two numbers over there. What are the two numbers over there? Oxidation number. Oxidation numbers, which is the charge of the ion after losing or gaining electron. This one is the cation, and this one is the anion. And you know how we call this in chemistry? This is the Lewis structure. A structure for ionic compounds. Okay, I know that you're not paying attention, but still I'm creating a video over here just to explain that to you. Oh, miramos, how we're gonna write the chemical formula. I don't know if some of you remember that. Do you remember how to dance, baby, dance? Remember that you have to dance, disco, fiesta. So,
I remember a little bit.
Okay, what are you gonna do? See, you are going from the oxidation numbers all the way through the subscript down here. You remember that I was doing that dance, baby? You have to dance when you're writing the chemical formula. So the chemical formula is Mg3N2. These numbers that you have over here are the subscript. And what is the information that you are getting from the subscript? Is the number of atoms that are involved in the compound. For 3 atoms of magnesium, you need 2 atoms of nitrogen. Miramos, how are we gonna name them? Or how are we gonna name this ionic compound? See, the fact that we have a subscript in there is gonna change the steps. No, chemical name. Okay, my beautiful students, I know that some of you have high expectation for your future. Getting into medical school is nothing but easy. Did I say that right? See? Nothing but easy. What are you trying to say with that sentence? That it's easy to get into medical school? I don't know much about grammar. See, when you're saying getting accepted into medical school is nothing but easy, what does that mean? That it's easy to get into medical school? They are not
Yes,
paid.
I'm pretty sure it's anything but easy.
No, but I want to say that it's easy to get into medical school. Am I saying that right? It's nothing but easy. No? No?
Yeah, in that case.
Yes. It's nothing but easy when you know biochemistry. Okay? So, yeah, I know that some of you want to be neurosurgeons, and you want to be pediatrician, and you want to be, you can wish to do whatever you want with your future. That is, you don't know chemistry, you know where you're going. You're going to get in the hospital to work as a nurse. Okay, so if I were you, and we think your future plan is to become a doctor, pay attention to this. Okay, how are you gonna name this ionic compound? The cation is gonna change the name. It doesn't matter if you have a 3, a 4, a 10, or a 25, okay, by the way, that's impossible. But it doesn't matter the number that you have as a subscript. The cation, magnesium. A ver, let me see with 2, no, magnesium. The cation never changed that name. By the way, I'm creating an application with a computer science teacher from another school just to name ionic compounds made of metal in representative group and monoatomic ions. Why monoatomic ions? How many metals do you have? How many non-metals do you have at the magnesium? Only 1. What's gonna happen to the anion? The anion is gonna drop the ending of the element's name, and what are you gonna add? Nitrite. That's the name of your ionic compound. Questions about that? Do you want
Wait,
to know?
miss, for the anion, the subscript doesn't matter either?
Doesn't matter at all. For ionic compounds, the subscript that you have over there doesn't matter at all. The cation never changes the name. The anion you have to analyze. Remember that you can have a monoatomic ion like the one that I'm showing you right now, or you can have a polyatomic ion, but later we're going to talk about that. When you have a monoatomic ion, how are you changing the name of the monoatomic ion? You are dropping the end of the element's name and then you're adding IDE. It doesn't matter the number that you have under that monoatomic ion. Questions about that? No? Another example, because you're going to be doing all of this in your homework or in your assignment. You're going to be doing all of this. You want another example? Okay, whatever. They are not talking. So right now we are going to combine, let me see, aluminum. We are going to combine aluminum and, let me see, we can combine aluminum and carbon. Okay, remember, for this part of the lesson, we are going to be using a different approach. Instead of using the electron configuration, we are going to be using, see, the information that we can get from the periodic table. And then we're going to start with aluminum. Aluminum is in group 13. Okay, you cover the one, you have a 3 is left in there, meaning that aluminum has only 3 valence electrons. On the other hand, you have carbon, that is a nonmetal located in group 14. Cover the 1, the 4 is left in there, meaning that carbon is going to have 4 valence electrons. 4 valence electrons organized this way. Okay? So you were learning in my class that in order to reach chemical stability, aluminum, since aluminum is a metal, is going to be losing the 3 electrons, and by losing 3 electrons, it's going to become positively charged, and that charge is going to be equal to 3. Why 3? Because those are the electrons that aluminum has in the last level of energy. On the other hand, then you have carbon that instead of losing electron is going to be accepting 4 more in order to reach chemical stability. Why accepting them? Because remember that carbon is a nonmetal. By accepting the 4 of them, it's going to become a negative ion with a charge equal to -4. This is the cation over here. This is the anion over here. Okay, the cation is the one with the positive charge, anion the one with the negative charge. And what you have here in front of you is the Lewis structure for an ionic compound. And over here you have the oxidation numbers. Oxidation. What are the oxidation numbers so important? Because those are the ones that you're going to use to write your chemical formula. See? You go from the oxidation numbers all the way through the subscript. And when you're putting them down, you are putting the numbers down without the charge. Carbon 3. See? You dance, baby, dance. Remember, you go from the oxidation number to the number of atoms that are involved in the compound. For 4 atoms of aluminum, you're gonna need 3 carbons. This is the chemical formula. What is the chemical name for this compound? Okay, aluminum is the cation, the cations never change the name, so aluminum is gonna continue as aluminum. And then the anion you're dropping, remember, is carbon. See, you are dropping the ending of the element's name and then you are adding IDE. So it's aluminum carbide. Okay, aluminum carbide. It doesn't matter the numbers that you have at the subscript. The strategy just to name ionic compound is the same. You look at the cation. What is the name of the cation? The cation is not going to change the name. And then you look at the anion. And the anion, you're going to drop the ending of the element's name and then you're going to add IDE.